Hi everybody, welcome back. Today we are going to be looking at the area between two curves. Previously, we've talked about how to find the area between the x-axis and one curve, and the way that we have done that is with a definite integral. So if I wanted to find the definite integral from -4 to 1, if I wanted to find all of this area, I can find it by taking the integral from -4, definite integral from -4 to 1 of that formula x squared plus 4x plus 5, and don't forget the dx. And then we could use our calculator to evaluate this for us, or we could take the antiderivative and substitute in and then subtract. Well, today, instead of finding the area between one curve and the x-axis, we will be finding the area between two curves. And the way they do that is with this formula when we are working with respect to x. So I'll take the definite integral from a to b, so from the boundary. So here's the left boundary will be a, the right boundary will be b, of f of x, and if I look at my picture, I see that f of x is the top curve. So top. And minus g of x, the bottom curve. So pretty much definite integral from top to bottom, top minus bottom with respect to x. So let's do an example. So let R be the region bounded by the functions f of x equals -x squared, g of x equals -1. It says find the exact area of the region. If it says without using a calculator, that's okay. We are going to use a calculator in this lesson. So I'm going to do, since I can see that there's a top curve and a bottom curve on this shaded region, I'm going to do the formula, the integral from a to b, and it looks like these two graphs intersect at -1. So from -1 until the other part where they intersect, +1. I'm going to take the top curve minus the bottom. And I'll do this with respect to x. We need that dx on there. It's super important. So then I have to look at my two functions and decide which function is on the top. Well, x squared is a quadratic function, which makes a parabola. -1 is linear, and that's a horizontal line. So I know that my top curve is -x squared, and my bottom curve is -1. So now I can set up the definite integral from -1 to 1 of f of x, which is -x squared. So let me make that blue. Minus the bottom curve, -1. And then I don't want to forget the dx. Now if I want to simplify, I can. The definite integral from -1 to 1 of -x squared plus 1 dx. And then I'm going to grab my calculator. Grab my calculator over here. And if you type, I've got a Desmos calculator pulled up. And if you type in the letters int, the definite integral will pop up. -1 to 1 of -x squared plus 1. And then we need to have a dx to make sure it works. We also need parentheses around what we're taking the integral of. And then the answer will pop up automatically, that 1.3 repeating, which is the same as 1 1/3. So 1.3 repeating, or 1 1/3, or also 4/3. Now, the other thing that you can do, if you're having trouble figuring out which curve should be on top and which curve should be on bottom, you could also graph each function. -x squared is, that's it, that's 1. And then the other one, -1. I should type y equals on both of these so that they'll actually graph. And then I can see this image here that they're showing. Now I only want from, well, that's the wrong picture. Go back. That's the right picture. Let me pull Desmos back up. There it is. Okay, here's the right picture from -1 to 1. So I could click on here and see those intersection points from x equals -1 to x equals +1. And you will have to do that on a few of yours. Sometimes you'll have a few like this where the intersection points are a little more difficult to see. So you will need to graph those on Desmos to find the intersection points. So I've got Desmos pulled up here. I'm clicking on my intersections. I'm going to label. So from x equals -1 point, where was it? There we go, -1.468 to x equals 1.135. Those are x. Whoa, those are x values. Okay, so now when I go to set up my integral, can't see where I am. When I go to set up my integral, I'm going to make it start at -1.468 to 1.135 of the top curve, which looks like it's this straight line. So that would be -x as the top, -x, minus, and I want to subtract the bottom curve, so I want to subtract the entire 3x squared minus 5 dx. And then I can type this straight into Desmos. So typing it straight into Desmos, let you see the whole thing. -x minus 3x squared minus 5. Make sure that you use parentheses around the whole thing. That's approximately -8.822688, and they want the nearest thousandth, which would be 10th, 100th. That would be 3 decimal places. So I would say about 8.823 for this one. Sometimes you'll be given curves and it's divided up into 2 areas. So sometimes, see if I have, let's go backwards. I just switch views. Sometimes you'll have the curves that at first one curve is on top and then they intersect and then the other curve is on top. So what that means is you'll just need to split it up into 2 regions. You'll need to find the area of region 1 and then the area of region 2. So first I would start by finding the area of region 1. Finding the integral from, looks like it's going to be 0 to whatever this intersection point is. So I'm going to graph that on Desmos so I can find that point. So here it is on Desmos. I'm only wanting to find this region where my mouse is and then this region. So I need that intersection point right there, which is approximately 1.397. And if you find that you're getting your answers incorrect because maybe of decimal places, you zoom in on the graph. And if you need more decimal places, you can get more decimal places by zooming in correctly. So we want to keep at least 4 or 5 decimal places if we can in the middle of the problem, and that'll help us be correct to the right number of decimal places. So this is going to be x equals 1.3972. So 1.3972. So the integral from 0 to 1.3972 of the top curve, which is the curvy one, so the quadratic function, -x squared plus 4 dx. Nope, not dx. I'm not ready for that one yet. Erase. The -x squared plus 4 would be my top curve for the area 1. Minus the bottom curve. And so the bottom curve here would be 7.75 plus 1, because that says part. 0.75x plus 1, close parentheses, dx. And then for the area of region 2, it's going to start at this x value, 1.3972, and it will continue until this 2. And now this time the top curve is the linear function, negative x squared plus 4, minus the bottom function is now the quadratic. Oh, sorry, I did that backwards. The top function is now the linear function, which is 0.75x plus 1, minus, now the bottom function is negative x squared plus 4 dx. So I'll find this area, I'll find that area, add them together, and that will give you the area of the total region. Sometimes you have to do it on your own. So like in this picture, I would say, okay, right here, I would divide it into region 1 and to region 2 and add those two areas together. Now, so far we've been finding all of our area with respect to x. And so we can do find area with respect to x when it's easy to see a top curve divided by a bottom curve. So if I can see that this curve's on top, that curve's on the bottom, I can find that area by integrating from a to b of the top curve minus the bottom. That looks like FOP, but that says top curve. Come on, eraser. Top minus the bottom. We'll just say it says top. Okay. And the one thing you did have to remember is when you're doing that, it's with respect to x. So we had to use dx. Well, we can also do this with respect to y. And it's kind of helpful whenever you can't determine which curve is on the top and which curve is on the bottom. We can also find the area by integrating from a to b. But this time, the a and the b are y values. So the lower y value to the upper y value of the curve on the right minus the curve on the left. L-E-F-T, left. And when we do that, we need to do it with respect to y. Now, when you run into these on Delta Math, they'll have you set up two integrals, one with respect to x and the other with respect to y. So one being you're finding the area doing top minus bottom, and the other meaning that you're finding doing right minus left. So let's do top minus bottom first. To do that, I'm going to need to identify which curve's on the top. So this curve would be on the top, which is the curvy one. So that would be the natural log curve. So this is my top curve, meaning this one would be the bottom curve. So I'm going to need to know these intersection points, and I'll find those by graphing with Desmos. And as I look over here, it looks that it says round the limit values to 3 decimals. So 5.357, 5.035. And then this point is 0.464, negative 2. 0.304. So then what I'm going to do top minus bottom, for the x, I would say it would be the definite integral from this x value, which is 0.464, to this top x value, 5.357 of the top curve. The top curve was 3 natural log of x. Don't need that extra parentheses there. 3 natural log of x minus the bottom curve. Put it in parentheses. We want to subtract the whole thing. Dx. So for the x1, I would put 0.464, x2, 5.357, and then right here, I would put that integral. Now, if I want to do right minus left, then I'm going to need to identify the curve on the right and the curve on the left. So right here, I'm seeing this line is the curve on the right side, and then the curve is the curve on the left. So the curvy part is this part, so this is left. and the curve and this line is the one on the right. So now when I set up my integral, instead of using x values, I'm going to be using y values. So the lower y value, negative 2.304, to this y value, 5.035. Now I would love to just leave it as the right 3/2 x minus 3 minus the left 3 natural log of x. The problem is when I'm integrating, I have to do right minus left with respect to y. And these equations are with respect to x. So what I need to do is I need to change them. So my equation for the right side is y equals 3/2 x minus 3. I need to write it in terms of y, which means I'm going to solve this equation for x. So if you add 3 to both sides, y plus 3 equals 3/2 x. Then multiply both sides by 2/3. 2/3 y. 3 times 2/3 is 2 equals x. So now instead of 3/2 x minus 3, I'm going to replace it with 2/3 y plus 2. So now that's in terms of y. For the blue part, let's erase that. I have y equals 3 times the natural log of x. So I need to write this in terms of y. So I can do that by changing into exponential form. Let's see, I could divide both sides by 3 first though. So y over 3, or 1/3 y, equals the natural log of x. And natural log I can rewrite in exponential form knowing that this is base e. So e to the 1/3 y equals x. So I can replace this part with e to the 1/3 y dy. So that's what I would enter. So here in y1, I would do negative 2.304. y2, I'd do 5.035. And then down here, I would put this part right there. So that should be enough to get you through this lesson. You guys have a great day. I'll see you next class.